So we'll start with our quick look at the calendar. Today we cover section 5.3. It's the last section of material that's on our last exam. Wednesday coming up, our next class is a full period review. It's just a practice exam for our exam. What happens this coming Friday? No classes, no nothing, right? Thanksgiving and the Friday are both no class days here at GCC, which means our class is 1 week from today. All right, and again, it's going to be a little bit disjointed because our review day is Wednesday, but then our test isn't for 5 days. It's Monday next week. Questions on the calendar? Once we get that exam behind us, there's really not a lot left to the semester for our class. We'll have 3 more days of new material, and that's it in terms of material. Then we'll talk about this optional makeup day, and then there's a practice finals day. Actually, it looks like 2 days of practice finals at the end of the semester. So, like I said, once we get through the test, only 3 days more of new material, and then kind of wrap up stuff at the end of the term. Okay, as usual, there are lots of practice resources for you. You can take a look there. And we'll go ahead and start with the objective here. Catherine.
In this lesson, we divide binomials, simplified expressions.
Thank you. Olivia? 1.
X squared over
Okay, so let's fill in the blank. X squared on the top. What does it really mean if we're writing it all out? X times X. Good. Go ahead and write out the correct number of X's on the bottom. Okay, and then what can we do to simplify this? We can cross out. How many X's can we cross out?
2.
Yeah, we can cross off 2 because that's the fewest number that we see, right? 2 X's on top, cancel with 2 X's on the bottom. Really easy to make a mistake here. When you cross out everything, like we did on top, you got to replace it with exactly the right number. What number do you have to put up there? You have to put a 1. You can't put a 0. And some people just decide that the fraction line doesn't belong there anymore, and they'll just write x to the 4th because they'll see 4 x's down here. So it's really easy to make that mistake. But if you cross everything off, replace it with a 1. That's our placeholder every time. And so we get 1 over, and then how many x's are there? There's 4 of them, so that's x to the 4th. And we get 1 over x to the 4th, and that's it. And just like before, there is a shortcut rule that some of you guys are already guessing at right now that you will see in your next algebra class. What do we do with the powers when we see division like this? What can you do with 2 and 6 to make a 4? You can subtract them, right? 6 minus 2 is the 4. Okay, it's a rule, it works, don't memorize it. Don't, just write it out. That's what we're after this semester. Questions on that? Okay, let's go on to number 2, Caroline. Okay, just a quick detour over here. Suppose that we had something like this, 5x times 2x minus 3. And we wanted to expand this. This is our lobster claw, right? This guy comes in and hits that and hits that. 5x times 2x, 10x squared, okay. And then 5x times negative 3, negative 15x. Okay, so we've done that before. That's old. At its heart, this thing right here is a subtraction problem, right? It's 2 terms separated by a subtraction symbol. But this guy up here, at its heart, is a multiplication. Yes? And sure, you could argue it's also a subtraction because I do see a minus sign inside, but it's inside the parentheses. And if I don't look in the parentheses, but I just look kind of globally, like big picture view, that's something times something. It happens the second something is a subtraction, but don't get into the details. That's a product. It's a multiplication. So it's really easy to turn the multiplication into the subtraction by distributing. Today we go the other direction. Today somebody's going to give us a subtraction problem, 10x squared minus 15x, and say, hey, can you undistribute? What did it come from? And that means turn it into a multiplication. Right? And so the word factor means write as a product, write as a multiplication, or undistribute, go backwards. Turns out undistributing, factoring, is really useful. It's also quite a bit harder than multiplying through, than distributing. And you'll see a lot of it in your next algebra class. But we'll start it here today. Okay, so I'm going to show you the just looking method and then the write it all out method. The just looking method is really for people that are on the ball and with it, and if you get it, great, but if you don't get it, then don't sweat it. So like I'm talking to like the 3 people that can do this without writing it all out. So really quick, what's the biggest number that goes into 6 and 3? It's 3. I have 2 x's in the first term and I have 3 x's in the second term. How many can I take out of both? I can take 2 of them out because I have 2 and 3 to play with. I have a y in the first term. Is there a y in the second term? No, so we can't take it out. And we're going to put some parentheses. The 3 came outside, used to be a 6. What's still left over inside? It's a 2, right? Because we need the 3 times something to still be the 6. You had x squared. You pulled both of them outside. There's no more x's left in there. You had a y. We didn't do anything with the y. So what are we writing? We're writing a y. Still there. Then there's a plus sign. We're copying that symbol. Then we had a 3, but we factored out a 3, so we don't need to write a number anymore. How many x's did we have? We had 3 of them. How many did we pull outside? 2 of them. How many are left over? 1 of them. And that's our answer. Okay, so if you got that, super. If you didn't, super. But that's the what Sandy calls the just looking method. There's not a lot of description that we write. We just say a lot of stuff and write the answer. Okay, but for the rest of us, for everybody, including me, let's write it all out. So what we're going to do is take that original thing, and I'm going to, what am I going to do? First, I'm going to ask the same question I asked before, which is what's the biggest number that goes into 6 and 3? It's 3. You're going to take 6 and you're going to write it as 3 times something. 6 is 3 times what? 3 times 2. Then you're going to take the x squared and you're going to write it as x times x. And the y is just y. What's the next symbol originally? It's an addition, plus sign. 3 we're just going to copy. But x cubed we're really going to write all out as okay. Next thing we're going to do is circle everything that's the same in both terms. And when I say both terms, I'm going to try to highlight here the plus sign. The plus sign separates the 2 terms from each other. So what do you see that's the same in the first as in the second? What's the same number? 3. So I'm going to circle the 3 here and here. How many x's do we see that are in both? Is 2, so I'm going to circle 2 x's here and 2 x's here. Is there anything else that's the same in both? No, that's it, right? So we've circled what's the same in both. So now that we know what's the same in both, 3xx, where do we put that as we start factoring? we put it in the front. That's what we pull out of both. So 3x, but we'll go ahead and shorten it up as x squared. And maybe we can write this goes here, and it's the same as this guy. And whatever we circle goes in the front. Then I've got some parentheses. Okay. We've already pulled the 3x squared out. So whatever you see is left over is what goes in. So I see a 2 and also a y. So the 2y goes inside. And what else do I see in the second term? It's an x. Don't forget that plus sign. And we're done. And if you need convincing that this is correct, all you need to do is distribute this 3x squared into both and verify that you get exactly what we started with. Right? And that's a nice thing about all of these factor problems. You might make a mistake, but it's really easy to know whether or not you got it right or wrong by distributing and seeing if you get back to the original. Okay, last thing I'll say about this. In a case where you pull out the number and there's no number left, like in the second example right over here, this 3 came outside. Whereas over here, there was still a number left, right? The 3 came outside, but we still had a 2. Sandy makes this very good recommendation, is that if you pull the entire number out, you got to replace it with a 1. Make this a 1x. Now, you don't need to call it a 1x in this problem, but there are some problems where you are going to need that to be a 1. And so I'll say it one more time. If you circle the only number that appears there, you got to make sure you replace it with a 1. Okay? Questions on factoring? Okay. So the classwork today is just hardcore algebra with lots of simplifying. You're going to see some rules that you've seen before, and we're just trying to reinforce them, and then new examples from today. Raise the flag if I can help.